What up, Algebra 2 students? This is my sixth period conference location. Just a random room because somebody's in my classroom teaching a big old uh, advanced math class. So I'm going to record the video from here. It's not a bad setting. This is like the day two homework. This is when we start getting into substituting, combining like terms, um, order of operations. It's kind of short, but it's just good stuff to practice. This is stuff kind of that we covered in middle school, order of operations and substitution. Okay. It's very similar to our notes. So if you can follow your notes and go back to my lesson video, you can maybe understand the reasonings why we do things. Key to substituting, and what we're taking is -5 for A and 4 for B and -3 for C, is to substitute it in and just be careful. I like to use parentheses just to make sure I know what's going on. Big mistakes are made as you think this is -3. You plug that in, and all of a sudden the minus goes away, and you just go -3. It's not -3, it's -3. What I'd like to do after that, if we're just adding and subtracting things, is to get rid of these subtracting negatives. We know subtracting is the same as adding the opposite. Combine our positives and our negatives. This is 5 negatives, 4 positives, 3 positives. I have 7 of something. I owe 5. After I give away the 5, I have 2 left. Same thing here. Let's just be careful. When we substitute, it's helpful to use parentheses. Maybe right now it's not important, but later it will be in other examples. I now know that's -5. This is going to be plus a -4. This will just be helpful to do. And then it's like, okay, I owe 5, I owe 4, I owe 9. I have 3. You could do this in any order. I owe 6. It's like, here's 3. How much do I have left? It's like we take away 3 negatives with 3 positives. Boom. But I still owe, or I have -6. -5, 4, -3. Multiplication, just like addition, can be done in any order. If you get rid of subtraction, that's important. Then you can add in any order. And multiplication, you can multiply in any more order. I'll just multiply like this times this times this. But if we want to do it in a different order, you see it's going to be the same answer. 4 times -3 is -12. -12 times 5 will be the same as this. You can do -5 times -3, +15. +15 times 4 will be the same as this. We have 3 groups of 20, 20, 40, 60. We have -5 minus 4 and another minus -3. Okay? Getting rid of subtraction because I don't like it. Subtracting a negative is the same as adding a positive. We realize we have -5 plus -4 plus +3. It's the same as this. How did that work out? I messed up here. My apologies. -5 minus 4 plus, this should be -3. Oops. Yo, fam. Teachers, they make mistakes too, and it's okay. This is -9 plus 3. This is -6. We just write down the numbers again. -5, 4, -3. Okay. -5 over -3 times opposite negative of b, which is 4. Okay, so -5 over -3 times -4, which I'll put over a 1. There's different ways to handle these negatives. Like a negative divided by a negative is a positive. I could just like get rid of them now, make this a positive and a positive, and then multiply across. Or multiply across and then say negative 5 times negative 4 is positive 20. Negative 3 times 1 is negative 3. Can't simplify this, can't divide this by 3, can't divide this by 2, so we're done. So can I get a better angle here? Sure. Just see me relaxing here. Okay, the opposite of B times the opposite of A. It's very important. It's not negative 5, it's negative A. Negative 5. So this is negative 4. Now, an opposite of an opposite, a not. I'm not hungry. So you're hungry. I got to stop talking. Like, I'm not a good teacher. Negative times a negative is a positive. If you're not a good teacher, what's that mean? Negative 5 divided by 4 over negative 3. Remember, dividing fractions is the same as multiplying by the reciprocal. Negative 5 stays. This turns into negative 3 over 4. Turn the 5 into 5 over 1. Multiply across. Positive 15 over 4. Can't divide this by 3 or 5. Those are the only things that go into 15. Kind of wish that I had this as like A times negative A over B border. B times negative B. If you want to use two sets of parentheses, you can. It's not necessary. It's like you're taking the opposite of what B is. B is positive, so it's going to be negative over negative 5. So this is 4 times negative 4 over negative 5. A negative divided by a negative is a positive. So negative 16 over negative 5 is positive 16 fifths. All right, getting into this. This is just something that's going to prepare us for when we deal with quadratics. Order of operations, PEMDAS. This parentheses means I have negative 3. This square means multiply by itself twice. So it's like negative 3 times negative 3. Well, since a negative times a negative is a positive, you have 9. This is different. This is what is 3 squared and then take the opposite of it. It's almost as if this negative is like a negative 1. Negative 1 is the same, negative 1 times something, like negative 1 times 5 is the same as negative 5. So whenever you have a negative, you could put and replace it with a negative 1 times. It's fine. So this is negative 1 times 3 squared. Well, order of operations says work with the exponents first. 3 squared is 3 times 3, which is 9. And this becomes negative 9. This is important when substituting, like positive 4. This is negative 4 squared, which is negative 4 times negative 4, which is positive 16. But this is essentially take the opposite of 4 squared. Square 4 first, then take the opposite. Just like this. Now we go this way, like just trying to trick you here, but don't get tricked. This is negative 3 times negative 2 squared. Don't multiply the negative 3 and the negative 2 first. Multiplication comes after getting rid of exponents. So get rid of this 2 first by squaring negative 2. So it's like negative 2 times negative 2 is positive 4. Now we can do positive 4 times negative 3. Cool. Negative 2 times Let's think of this as negative 1 times 1 squared, right? The negative can be turned into like negative 1 times. If you want it, if it helps you. If it doesn't help you, don't do it, but just trying to show you, like, here are the rules. This is a game. The game of math has rules. We must follow rules. I'm actually like leaning back so much, but I don't know how to fix it. Lock. Whatever. Now, 1 squared gets taken care of. Just 1. Negative 2 times negative 1 times 1. Positive 2. Now let's substitute. These are tricky. I'm throwing tricky ones at you for a reason. Just to see, like, can you follow the rules? Can you play the game? That's a negative. Maybe we think of it as negative 1 times. What is A? Negative 3. What's happening to it? Being squared. Negative 3 times negative 3. Positive 9 has to come first. We're not going to make this a positive 3 and then square it. That's breaking the rules of the order of operations. We must square this first, exponents, then multiply the negative. This ends up being negative 9. They're tricky. But, I mean, like, games are tricky sometimes. Puzzles are tricky sometimes. Be careful. Negative A. Negative 1 times A. That's happening in the parentheses. Let's write that in here. Maybe that's easier. I haven't done this. I didn't do this for the notes, but maybe this is easier. Negative 1 times negative 3. Negative 2 times negative 1 times negative 3. I'm going to do that first. Positive 3. Now I have to do positive 3 squared first before I multiply by negative 2. These are the rules to the game. Follow the rules, and you'll win the level. When combining like terms, understand you can only combine similar types of fruit. Okay? For example, negative 5x. That means you have like 5 of these x's. 5 of the x's. What are the x's? I don't know. Could be a number, but let's just keep it as x. Let's call them apples. Now, I owe 5 apples. Okay? I also owe 6 apples, but I have 1 apple. I owe 5, I owe 6, I have 1. Well, what about this 3? 3 is not an apple. It's just the number 3. Or you can think of it as a different type of fruit. It's an orange. I can't combine the 3 oranges with all of my apples. You can't just say 3 plus x is 3x. It's not right. This is an apple. This is 3 oranges. You have an apple and 3 oranges. You don't have 3 apples. So, wrong. Don't do that. Be comfortable sometimes being like, this is what I have. 3 oranges, 1 apple. So that's how I try to explain like terms. Apples go with apples, oranges go with oranges, so on and so forth. I owe 11 apples. I have 1. Okay, here's 1. I owe you 10 apples. Still have 3 oranges, though. That's nice. Distribution. You have 2 groups of an apple and 4 oranges. You can't add this apple and 4 oranges together. They're not the same type of fruit. It's an apple and 4 oranges in a bag. You have 2 of those bags. Well, what do you have? 2 apples, 8 oranges. This is distribution, so you kind of figure out what you have. 2 apples, 8 oranges. We multiplied by everything, so we know what we have. 2 groups of a bag of 1 apple, 4 oranges. Well, if you have 2 groups of that, 2 apples, 8 oranges. And somewhere else, I have 5 apples and an orange. What do I have? Well, a total of 7 apples, 9 oranges. Now, this is tricky. I owe an apple and I owe 2 oranges. I owe and owe. This is like not a not. Tricky. This is one of those examples I was telling you, like a negative in front of something, just put it as a negative 1 times. Turn that into plus or minus. If you owe, if you not a not, it ends up being a positive. If you distribute this, it's probably better not to explain this in real world terms. I'm not a good teacher, guys. Negative 1 times x, negative 1 times negative 2. Oh, it turns out I actually have 2 apples, 2 oranges. I also have 3 apples. So after distributing this, you realize what you have. You actually owe an apple, you have 2 oranges, you have 3 apples. Well, if you owe an apple and you have 3 apples, you have 2 after you give away 1. And you have 2 oranges. Oh, look what we got. Y squareds. Hey, avocados. You can't add your avocados to apples. You can't have your avocados to oranges. 1 avocado and 1 apple do not combine to be 2 pineapples. Nope. They don't combine to be 1 pineapple. Nope. This is different than this. They're different things. So you can't combine them. You just leave it like this and be comfortable with that. Okay, sweet. I have an avocado. I have an apple. X's are apples. Y's can be apples too. Good stuff. I got 2 avocados. I got 4 avocados. Oh, I have 6 avocados. I got 3 apples. I got 5 oranges. Look at me. I got half of an apple. I owe a 1/6 of an apple and 4 oranges. Yikes. Well, again, that negative turns into a negative 1, can be distributed. Maybe we realize what we actually have. I owe a 1/6 of an apple. I owe 4 oranges. Well, I have 2 apples. I owe 4. Sorry, I have 2 oranges. I owe 4 oranges. I owe 2 oranges, right? The only way I can add a half and a 6 if they're same types of slices, just like fruits. It's like if you have fractions, think of it as slices of fruits or slices of pizza. Let's think of it as a slice of an apple because we're talking about X's being apples. I have half of an apple and I owe a 1/6 of an apple. Okay. Well, the best way to do this is to figure out how many halves are 6. Like how many 6 go into a half. Make them like slices. Like slices can be done, again, remember, by making and creating a common denominator. 1/2 of an apple is the same as having 3 1/6 slices. Pizzas are typically cut into 8s or 6s. Let's say the big pizza slices cut into 6s. That's tough, actually, 6 slices, because it's like 3 on one side and 3 on the other side. No, that's actually easy. Anyways, I'm not going to think about that. I have 3 1/6 slices. I owe 1/6 slice of an apple. I have now 2 6ths. Oops. 2 6ths of an apple. I also owe 2 oranges. Well, 2 6ths of an apple, turns out, is the same as 1/3 of an apple. Okay. I have 1/3 of an apple. I owe 2 oranges. I have 4 bags of an apple and 4 oranges. What do I have total? 4 apples, 16 oranges. Just distribute it. Oh, guess what? I also have 8 avocados. I'm done. I can't do anything. You got apples, you got oranges, you got avocados. That's all. Don't combine them because they are not the same. Maybe you're going to list them in terms of what you like the best. This is called like standard form, going from like the biggest kind of degree to the least to something without a variable associated with it. I don't know. I like avocados more than apples, more than oranges. Um, this one's tricky. We have this in our notes. I'm okay if we like skip this, but I'm not going to. Let's do this one first, and then I'll tackle the other one. We got 2 sets of parentheses. This bracket is another set of parentheses. I'm going to first worry about this bracket. I have 5 groups of an apple and 6 oranges. I have 5 apples and 30 oranges. Hey, guess what? Somewhere else I have another 7 oranges. I have a total of 37 oranges and 5 apples. Oh, actually, I have half of that. I have half of 5 apples and I have half of 37 oranges. Split this in half. Oh, I have 5 halves of an apple. I have 37 halves of oranges. If I was able to, like, if this was 6 and 38, 6 divided by 2 is just 3, But since it's 1/2 times 5, and when I multiply this, I get 5 over 2, I'm stuck there. I have 5 halves. What is that? 2.5, right? 5 halves. This one is it's tricky. A lot of different slices. So I have 3 bags of b over 4. Now b over 4 can be written as a quarter b or a b quarter. It's tough to think about it as a quarter b, but 1/4 b is the same as b over 4. It might be easier to think about it like that. That way, if you distribute it in, you multiply by 3, you can just say, oh, 3 over 1 times b over 4 is 3b over 4, or 3/4 times b. Whatever way you want to do it, either write it like this or write it as this. Okay. 3 times 5. 5 apples, 3 times. 3 groups of 5 apples, 15 apples. Sorry, oranges. I owe this. All right, well, let's just say I owe this amount and I owe that separately. That's like distributing this -1. I have 3 groups of this. Well, let's treat them separately. Means I have 3 b over 2s, or 3 halves of a b, 3 halves of an apple, and I owe 6 oranges. Now, again, I don't like this one because, like, we end up with fourths, thirds, halves, 15, owing 6, owing 2/3. It's a lot of, like, things that I have to make into like terms. And, if we have a calculator, we can do this. This is just like practice working without one. So you just have an understanding of numbers a little bit better. I feel like when we use calculators, we lose an understanding of what we have. We try to do stuff that isn't allowed. We don't use calculators, maybe we have to have a better understanding of our numbers and our situation and what we have. So, anyways, what I would do is just figure out, well, if I have 15 oranges and I owe 6, I have 9 oranges. I still owe 2/3 of an orange. I'll figure that out. So I have 8 1/3 oranges left, but like, what's that equivalent to? Well, I like how a lot of you will go, it's 8 1/3. We like improper fractions. We're going to like things not as mixed numbers, 8 plus 1/3. So we're going to turn this into 27/3. And then we are going to owe 2/3. I have 25/3. So 8 1/3 is 25 thirds. Maybe you could have figured that out by yourself. Great. If not, no big deal. So let's just remember that. I have 25 thirds of oranges. Now, what about all these apples? I've got 3/4 of an apple. I owe 7/3 of an apple, and I have also 3/2 of an apple, or 1.5 apples. The only way to be able to add these together is if they are like slices. Instead of fourths, thirds, and halves, let's turn them into something that they can be compared to. Let's turn the fourths into twelfths, the thirds into twelfths, and the twos into twelfths. It's almost like take 2 times 3 times 4. All those denominators, multiply them together, and you'll have like slices. So that's what I'm going to do. So I know how many apples I have or owe. I'm going to multiply this by 3 times 2, which is 6, to get twelfths. I'm going to multiply this by 4 times 2, which is 8. Whoa. I'm going to just multiply this by... Whoa. I don't do 4 times 3 times 2. That would work. You'd have 24ths. My bad. Sorry. Twelfths just means multiply this by 3, multiply this by 4, multiply this by 6. It would work out if you turn it into 24ths. But let's multiply this by 3 to get 9/12ths of an apple. You can put the B in front, or you can keep it up here. Multiply this by 4 to get negative 28/12ths that I owe. Multiply this by 6 to get 18/12ths that I have. Now we have like slices. It's easy to just like, oh, this is a 12th, this is a 12th, this is a 12th, this is a 12th, this is a 12th that I owe. I owe 28. That's a lot. But I have 18 and 9. Well, 18/12ths and 9/12ths, let's think. 19, 20, 21, 22, 23, 24, 25, 26, 27. Okay, 27, that's the easy way. How about 18 times 10 minus 1? Because 9 is 10 minus 1. 18 times 10 is 28. Minus 1 is 27. How about, I remember 9 times 3, because 9 times 2 is 18, times 9 times 3 is 27. Whatever. Turns out, I have 27/12ths of apples, but I owe 28/12ths of apples. Put it all together, and I'll put the answer up here. I owe 1/12 of an apple, but I have 25/3 of oranges, not equal plus. Okay? If we're comfortable with numbers, comfortable with this stuff, this is the important middle school stuff, setting ourselves up for success. Maybe we're a little bit more confident. Next class, solving equations. See if we can, relearn that. Go from there. Thanks.